Okay. Any ideas? Any ideas? No? Anybody have any ideas? Oh, people are shaking their heads. A lot of people shaking their heads. Bangti, do you have an idea? I think you have an idea actually.
We were talking about
What's the height? Tell me what the height of this rectangle is. Right, we're cutting at time x. Right. We're cutting. We've moved x units from the. Right. Here's the axis. Right, here's the axis. We moved x units in this direction. What's the height? What's the height of the slice?
the height is the same as the.
It's the same as this distance. It's x, right? Because it's a 45 degree. It's a 45 degree angle. Yeah, you slice at 45 degree angle, so you move over x. The height has gone up. Right? This is going to be a straight line. This is just the line y equals x, right? So the height of your thing is x, right? Okay. So what about the width of your rectangle?
You use r squared minus.
Exactly. Yeah. Right. Because this circle is a radius 3, right? We have a circle radius 3, right? So, right. So this thing is going to be square root of 3 squared minus x squared, and then on the bottom you have negative 9 minus x squared, right? So what's this length? The length is going to be 2 times root 9 minus x squared. Right? You guys see that? Right. So the area then is going to be x times 2 root 9 minus x squared. Okay, and so the volume is going to be the integral from 0 to 3 of 2x root 9 minus x squared dx, which is very easy to integrate by u substitution. Okay. Okay, any questions? Okay, so okay, maybe one last problem. I was going to introduce the next method, but I think there's no time for it. Anyway, the next method wasn't scheduled to be introduced until tomorrow anyway. So let's finish up with one more washer problem, which is this one. You have between 0 and 1, you have y equals the square root of x, and you have y equals x squared, and you rotate that thing around x equals negative 2. Okay, so you take that object and you rotate it around x equals negative 2, right? And you get this. You get this thing. Okay. So this is your axis of revolution. Axis of revolution. Right? And I'd like to. So you take this solid guy. You take this area. You rotate it around, and you get this object. Okay. It's like just the outside, like a bowl without the bottom, basically. Okay. What's the volume? So write down the integral. Write down an integral x expressing the volume. Okay. Turn to somebody else and talk for a second, and then tell me what the answer is. So, what do we do? Right. We're going to take slices, right? Right. Again, we're using the method of washers, right? So you take this slice, this little slice here, and then you rotate that guy around, and you get this disc, right? You get this annulus. Right? So we're going to get the integral from what to what? From 0 to what? 1, thank you. Right? And what's the pi outer guy? What's the outer guy? What's the radius here? Well, x is going to be root of x, root of y, right? Quantity squared. Right? Root of y quantity squared minus the inside guy, right? Your x value is y squared, right? dy. Right? Okay. Any questions about that? No? Okay. Okay. We'll do more simple stuff next time.